So starting off, this is section 7.5 in Big Ideas. Right. If you want to follow along, it starts at page 398. So there's other information and more examples there. Get my camera to lock. And however you're writing these notes, my objective for you is that students will be able to use properties of trapezoids. Literally, that's going to be it as far as this goes. And then, yeah, we'll just start there. So a trapezoid you're probably already familiar with. It is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called bases, which will be here and here. Okay. The non-parallel sides are called legs, just like in like triangles. So this is a leg, and this is a leg. So also within this picture, we get these to be parallel, so we'll put our parallel markings there. Okay. Now the other part of this picture is that we have what's called base angles. The base angles of a trapezoid are two consecutive. Remember, that means right next to each other or nothing in between them. Angles whose common side is a base. So it's at either end of the base, which means it's going to be like here and here. See how the common side is the base? Or you can also do the other side. This is also base angles because they're connected by the base angles. Okay? A trapezoid always has two pairs of base angles because there's two bases. Now, we have another, and this is a generic one. We have another picture where you have isosceles. Okay, so if the legs of the trapezoid are congruent, so if you also get that this is congruent to this, exactly the same, then we're going to call that isosceles. Okay, we still have the parallel, and we still have the base angles, but for right now, those two, in fact, I'm going to highlight that. This is isosceles. And then last, we have what's called a right trapezoid, which means trapezoid with at least one right angle. And that's it. Questions? So we always start with definitions. I know you've seen these before because every kid has seen this before geometry in high school. But this particular one, this example says show ORST is a trapezoid. So to meet that definition, all you really need to do is show that it has, look at the definition, exactly one pair of parallel sides. If you recall how to do parallel, that means that you need slope. So you basically have to show the slopes of all four sides and then make sure that only one of them match. So the slope of RS we're going to look and see if it's equal to the slope of OT. And then we're also going to check the slope of our O and see if it is the same as the slope of ST. So our S is going to be 4 minus 3 over 2 minus 0. Y is over the x's. This one's going to be 2 over 2 minus 0. And it's going to be over 4 minus 0. So this is going to be 1 on the top, 2 on the bottom. And this is going to be 2/4, which is also 1/2. So these are parallel. And then this other one, you're going to check this way and this way. So it's going to be 3 minus 0, or 0 minus 0. It's going to be 4 minus 2 over 2 minus 4. You may notice that this right here is going to give you 0 on the bottom of a fraction, and that's going to be undefined. So RO is not parallel to ST. Okay. Since exactly one pair of sides is, should say opposite sides, is parallel, then we can say that ORST is a trapezoid. Okay. Now the second part says isosceles. Check to see if it's isosceles, and then which means that you're going to check this against this with distance. Okay, so to find RO, you can clearly see that the distance is 3. ST, because it's straight up and down and it's not slanted. Okay, but ST, the distance will be 4 minus 2 squared. It's 2 minus 4 squared. So that's going to be 4 minus 2 is 2. 2 squared is 4. Plus negative 2. Okay, so 3 is not the same as 2 root 2. So you can say that, well, RO is not equal to ST, so it is not isosceles. So that's a little bit of work. Also, this is in the other video as well as your book. So we're going to move on. Now that we did some definition problems and you've got a little bit of practice on the coordinate grid, now we're going to talk about the other theorems. So, at least for a trapezoid, we have 3 theorems. I believe if the trapezoid is isosceles, then each pair of base angles is congruent. So I might abbreviate it like this. Trapezoid ABCD is isosceles, then angle A is congruent to angle D, and angle B is congruent to angle C. Of course, I should label this, right? A, B, C, and D. I know that it is parallel here, parallel here. I get that it is isosceles, which means that angle A is congruent to angle D, and angle B is congruent to angle C. Again, this is a theorem that we can use And I'm going to go ahead and turn it over to the second page for a couple more theorems. We also have the converse of what we just wrote. Okay, so if trapezoid ABCD, which I will label in a second, has, these are base angles, angle A congruent to angle D, then trapezoid ABCD is isosceles. So it goes both ways. Got A, B, C, D. We know that this is parallel. We know this is parallel. They're saying if I know that I have A congruent to D, and this would be or B congruent to C, so you could do both of those. If either of those things happen, then what you get is you get this. Okay. Just kind of nice, don't you think? And then our third theorem of the day is diagonals. So again, if I go ABCD, a trapezoid is isosceles if and only if, which means it goes both ways. You don't have to have a converse. Its diagonals are congruent. So I just want to draw a straight line. I don't have my ruler with me, but I do have something else I can use as straight edge. So what this says is that get trapezoid ABCD, and it goes both ways if and only if AC is congruent to BD. So if you get that AC is congruent to BD, then you get that AB is congruent to CD, meaning okay, goes both ways. Any questions? So we've got three really powerful theorems here, really two if you count this one as the one that goes if and only if. We're not going to do this particular proof right now. It is in your book. I can show it to you probably tomorrow. But for right now, let's just continue with the problems. So this is how we actually use those theorems. If I have MQ equal to 7y minus 6, and I have LP, 4y plus 12, find the lengths of the diagonals so that this trapezoid is isosceles. This theorem right here says it's isosceles if its diagonals are congruent. So, and vice versa, if its diagonals are congruent, then it's isosceles. So really what we're doing is we're setting MQ equal to LP. That's all. And then we can substitute what they're equal to. So 7y minus 6 equals 4y plus 12. And you subtract 4y from both sides. So we'll get 3y here. I'm going to add 6 to both sides. And I'll get 18 here. And I'll divide both sides to get y equals 6. Have I answered the question? Find the lengths of the diagonals. No, I still have to keep going one more step. So if y is 6, then I need to just plug it in either here or here. I should get the same number, and I'm going to use this one because the numbers look easier to me. So 4 times 6 plus 12, oops, I didn't need to do that, is equal to, here. That's what's nice about erasable pens. Okay, so 24 plus 12 equals LP. 36. Of course, you should get 36 if you plug it in for MQ also. Again, this is my pausing for any questions. Okay, it's a lot to remember. 40 different terms, but I've got one more theorem for you. And this one is very similar to the one you already have, so it should look familiar for you. Now, the mid-segment of a trapezoid. Mid-segment is going to be, a lot. It's the same definition. It's a segment that connects midpoints. Okay. So let's just remind ourselves what that is. It's a segment that connects midpoints of two sides. We have a theorem. Okay, and the theorem says that the mid-segment of a trapezoid is, first of all, parallel to each base, so that's where you get that triangle from. And also, and this is the important part, it's half the length of the sum of the lengths of the bases. So, got your bases here and here. You've got a short one and a long one. Let's say the same, but short and long. If you add this and this together and divide by 2, what you're really doing is finding the average here. So it's this plus this, and then divide by 2 to get the average. That's what it is. That's the base. And so I did want to just write this down. So MN is equal to the length of AB plus the length of DC, all divided by 2. So that's why it's half, just thinking it's taking the average. So we're going to do, we've got like 3 problems here that are very straightforward. You'll see them in your practice. In this diagram, MN is the mid-segment. Find MN. So PQ is 12, and SR is 28, which means MN is equal to 12 plus 28. You do those short ones, short and long, and then you divide by 2. So MN equals 40 over 2, which is 20. That's all there is to it. Now it's going to be a tiny bit, harder because we've got unknowns. So if we have unknowns here, we can still solve it with our algebra. Same equation, and it doesn't matter if it's sideways either. These two are the bases because they are the parallel ones. So it's these two bases added together divided by 2 is the answer of 22. So we're going to write that equation. 22 is equal to the top base plus the bottom base, all divided by 2. So all we have to do is solve for x. Now, because this is divided by 2, I'm going to multiply both sides by 2 to get rid of that first. So 2 times 22, and then I'm going to combine my like terms. So I have 5x plus 4. I do like to do that in a separate step. Now I can take away 4 from both sides, and I'm going to divide both sides by 5. So, and it says find x, we found x. Good, just checking. Finally, we have a third one where, look, this is given to you as the average. So that's like you don't know any of the n's. All it says is find this, n plus 6. But you have this formula. The mid-segment is equal to both bases added together divided by 2. Same theorem. The only difference is now we have n over here too. So again, I'm going to multiply both sides by 2. So I get 2n plus 12. Then I'm going to combine the n and the 3n. I'm going to add this. And I'm going to take away 2n from both sides. While I'm at it, I'm going to add 2 to both sides. I end up getting n is 7 So the mid-segment is n plus 6. It'll be 7 plus 6. And so the final answer I either enter into the computer or box on my paper is 13. Remember, you have to answer the question being asked. All right. I think that's the last one for today. Yeah. So then number 7, you have a trapezoid, JKLM. J and M are the right angles, and JK is 9. The length of this mid-segment is 12. Sketch the trapezoid and its mid-segment, and then find the length. So first, I know that these two are right angles, so I'm going to start like this. And it's telling me that J and M are the right angles. So it doesn't matter what this other side looks like. I'm just going to make it slanted. But it does matter what direction you go in. You need K and L. So K has to follow J, has to be here, and L has to follow K. So it has to go this direction. And it's telling me JK is 9. Let me mark this as 9. It's also telling me I have a mid-segment. Again, I'm sketching it. So my mid-segment is NP. And it's telling me that that is 12. Sketch the trapezoid and find ML. So this is what I'm looking for. This will be my X. Then same formula, 12 is going to equal 9 plus X divided by 2. It's the average of the bases. So again, I'm going to multiply both sides by 2. I'm going to take away 9 from both sides. And I'm done. Done for today anyway. So that's it for trapezoids. Kites will be tomorrow.